Hello, Srikar.
Hi.
Welcome to the 4th edition of the Data Innovation Summit here in Stockholm. It's your second event with us, and we are pleased to host you again.
I'm very glad to be here once again.
So please, just if you can shortly introduce yourself.
As you said, my name is Srikar. I'm actually from Volvo Cars, from the Active Safety Department, working on autonomous driving. So I'm leading a team on machine learning and artificial intelligence and data analytics. Prior to that, I had a background from PhD from Chalmers University, and also like a quite different background. I would say I worked like 5 years in the telecom industry.
Srikar, today you were presenting at the machine learning, deep learning stage, according to your expertise, and a presentation on Fast Semantic Proposals for Image and Video Annotation using modified echo-state networks. And I think this is a publication of yours that it is even online. But in short, can you please just do a short recap? How is this segmentation done and what are the benefits?
Yeah, I mean, if you say like for an image annotation, there are different ways of how you annotate the data. For example, if there's a image like you can only say like, yeah, this is surrender, this is where you locate. But when you go much deeper, I mean, the semantic segmentation comes in the picture. Where in an image, for each pixel, we need to say, for example, take a picture of this, I need to say is each pixel like you as like a person, that's a chair, this is a floor, and each pixel we need to label, a class label. So that's actually a very difficult task in the sense it takes a lot of time if you want to really annotate because there's so many pixels in an image. So in this work, we tried to come up with a framework that gives like a fast and accurate pre-proposals annotations for the image and the video streams.
Okay, so when we are at this segmentation, what are its usage in the automotive industry in this case in Volvo cars?
So very perfect extension of that previous question. So for example, I mean, semantic segmentation gives or allows you like a robust way of perceiving the environment. For example, if you consider like autonomous vehicle, and you need to find out the safe corridor where it has to travel, then the semantic segmentation is kind of like a free space detection or like a drivable surface, where you say to the autonomous vehicle, okay, these are the boundaries within which you can safely drive.
So, Srikar, if you allow now a bit of more of a generalized questions, we have about the latest trends in deep learning, which is really a hot trend still. And maybe an overhyped technology. The market value of it is projected to grow from 20 million in 2018 up to 900 million by 2025, which is like a huge difference. Okay, so any attempts, however, to discuss it both AI and deep learning as one and the same thing would be wrong. So, as a person who works with that, can you please make a distinction of what means? What is AI? What is deep learning? What makes them similar?
So I would say like a very good question. Actually, I had a recent interview at like a podcast. During that interview, I was trying to explain the same. Like, I mean, many people think they are the same, but of course they are not. I would say like deep learning is like a subset of machine learning, wherein like in machine learning, you need to like a 2 stages where you have like a data engineering or feature extraction part, then you do the classification or regression models. Whereas like in deep learning, this is kind of one. You just give your input, and this deep learning framework will just automatically extract the features as well as does the classification and the regression. Whereas when it comes to like artificial intelligence, it's one more step ahead of this. So these systems should have their own intelligence, which means like compared to earlier machine learning, deep learning, where you try to teach the system. But this system has to evolve on its own from the mistakes it has done from the past. So for example, one example could be for artificial intelligence is kind of a reinforcement learning. So the system will try to predict something, and based on that it gets a reward, whether it's good or bad. So it tries to update. It's like how a kid does, right? You touches, maybe it's cold or hot, and then he'll like, okay, maybe next time I shouldn't touch. So that is, I would say, like the self-intelligence or the artificial intelligence. So in that respect, reinforcement learning, I would say like one that is closer to artificial intelligence.
One last question, Srikar. As the main theme, main focus of this edition is accelerating data and AI innovation, and according to Forbes, AI is still being on the top of trends in 2019. So, from your perspective, what is your prediction about the automotive industry in the near future? Self-driving cars, maybe?
Yeah, I mean, yeah.
Volvo driving by itself?
Yeah. Yeah, we've been into this self-driving things from quite many years. I would say like the first and foremost that will maybe comes from these autonomous cars would be like specific use cases. I'm thinking of like, for example, maybe like a highway pilot, like where you can only drive in the highway based on AD certified roads. Another could be like the robo taxis, like the Uber and other companies who are trying to like ride sharing. That could be like one use case. And another use case I was thinking like autonomous car parking, where is you just go to a car parking area and then it drives itself and then parks automatically. Yeah. But I would say like we're still far away from like a fully autonomous cars that drives everywhere. I would still like quite some time.
But it's in the way. So
yeah, it's in the way. I mean,
the industry is working.
Yeah, it's working. Yeah.
Awesome. Srikar, thank you very much. Thanks to Volvo for always being with us in the event.
Yeah, it's a pleasure to be here. Yeah.
And thanks for this interview.
Yeah, thank you, Saranda.